Hi everyone, welcome to day 1, subtopic 3 of our AMC frameworks. And today we'll be learning Simon's favorite factor trick, also known as the forced factorization. So if we're given xy plus ax plus by all equal to some number where a and b are constants, we want to try to add something to both sides in order to force a factorization of this part to make it easier to isolate our variables. So there is a equation for that. So all we have to do is take the product of these two coefficients, multiply them together, and add that product to both sides, which will give us the factorization of this half of the equation. So we can write that out. X plus a times y plus b equals n plus a. And this allows us to find the variables x and y. So let's actually take a look at problem number 10 from the 2021 AMC 12B Olympiad exam. And we are given that two numbers are selected from a set of 1 through 37, so that the sum of the remaining 35 numbers is the product of these two numbers. So if we say that our two numbers, we can call them x and y. So what we know is that the sum of the remaining 35 numbers is the product of these two numbers. So we can say that x times y is equal to the sum of all these numbers. So that's the sum of all these numbers. We can call it s for now, minus the sum of x and y. So when they're subtracted. So minus x and minus y. So this is actually starting to look a lot like our formula from before, except it's a bit rearranged. But the key here is to rearrange this in order to make it look like that formula. So s here is actually can be calculated using a trick that we will learn later in the video in the framework. But this sum from 1 to 37 can be calculated as the product of 37 times 38, all divided by 2. So if you're not familiar with that, be sure to check out the link in the description. But for now, 19 on top and 2 would cancel out, leaving us with 37 times 19. So that is going to give us 7, and our answer is 703 for the sum. So we're going to go ahead and put that in. And if you didn't understand this, that is absolutely okay. So you could hand calculate 1 through 37. It would just take a lot longer. This is a little shortcut that we will learn about later. And now that we have this structure, we're going to try to rearrange it to get it to look like this. So let's do it. There we have our formula. So all we want to do here is add the x and y to the sides, leaving us with x plus y is 703. So remember that our coefficients here are what we want to multiply together and add to both sides. So here we have 1 times 1 is equal to 1. So all we have to do is add 1 to both sides. And from here we recognize that this is just x plus 1 times y plus 1. In its factored form, and simplifying the right side of the equation, we get 704. So now all we have to do is find two numbers from our list of 1 through 37 that will give us a product of 704 when each of those is added to 1. So here we recognize that 704 can be broken down into 64 and 11. And 64 is just 2 to the power of 6. So here we have our prime factorization of this number. And if we want our numbers to stay from 1 to 37 at a maximum, we'll give one of these 2's to the 11, leaving us with 22 on this side and 32 on this side, which fits perfectly into our set of numbers. Now we know that x plus 1 is equal to 32 and y plus 1 is equal to 22, leaving us with x equaling 31 and y equaling 21. And going back to our question, it asked us for the difference between the two numbers. And we can now conclude that the difference between x and y is 31 minus 21, which equals to 10. And that is it. We can confidently select choice E on our exam. Thank you so much for watching, and I hope you found this factoring trick helpful. And see you next time for topic 1.4, and happy problem solving. Bye bye!